In this exercise, we're going to delve deeper into variables and values in Python. Let's start with this first question. This first question is asking us to enter these values and assign each value to a variable that has a unique name. So for number 4, I'm going to assign the value 4 to a variable I call number, num. 3.41415, I'm going to assign it to a variable called pi for some obvious reasons. For the value 1.0, I'm going to call it 1. For the value 2 plus 4j, I'm going to call it comp for complex. Now, 2 plus 4j is basically 2 plus 4. That's the image. The j is the imaginary number, the square root of -1. You may have seen this in some advanced calculus course. If you did not, don't worry about it. We're not going to use complex numbers in this course. They are used mainly in scientific and engineering applications. They're not widely used in analytics. However, they exist in Python as a built-in data type, which is nice. And let's put another variable. I'm going to call it string1, str1, hello, and str2, I'm going to call this one str2 world. Okay. Now aligning the equal sign is not needed, but it just makes the code slightly more readable, so I just aligned all of them here. Next is asking us to report the type of each variable. How do we know the type of the variable? We use the function type. Now, again, without using the function type, we can know the type of the variable by looking at the cues of how it's formatted. An integer is formatted as the number representation. A float is formatted by having a decimal point, even if it doesn't have a decimal point. This number pi has a decimal point, but even if it did not, even if it was 3.0, we will get the 0.0 here printed for us as a cue that this is a float. Okay, let's take a look at number 1. Number 1 is also a float, and we can see that there is 0.0 here, although there is 0, doesn't have any added value, but it's shown to indicate it's a float. Same thing for complex. It will show with a j, even if the j did not exist, just to indicate that it's a complex number. So, for instance, if I subtract 4j from my complex, I get 2 plus 0j, although 0j doesn't have a value anymore, so 2 actually is equals to 2 plus 0j, but still Python show it as 0j for me to know that it's a complex data type. And finally, a string will show with the quotes. So hello will show with the quotes. Now, the string value is hello, there are no quotes. If you print string1, you're gonna get hello without the quotes. The quotes are shown for us to know that this is a string. I'll give you a more meaningful example here. Let's say the value of str1 is quote 4. Now, if you print str1, you're gonna see 4. If you print num, you will see exactly the same output, 4. So you will not be able to tell which one is a string and which one is a number. However, if you type in the variable name and you just execute the cell, you're going to see the quotes here, which is a visual cue for you that this is a string, although that the value in the string is 4. Right? It says 4 as a string. It's not equal to number 4. It's different than number 4. Okay, so let's get this to hello here. Same thing for string 2. Now, if you want to be sure, if you're not very familiar with those visual cues, the easy way to know the type is to use the function type. So if you do type and the variable name, you're gonna get the type of that variable. So int, float, and this one will be complex. This one will be str, and this one will also be str. So it's up to us. Either once we're familiar with those visual formatting cues, we don't need to use type, or we can use type to be safe. Now this question is asking us to try to combine these variables with these operators: plus, subtract, multiply, and divided. So we have to note that not all of these operators apply for all data types. Now for numerical data types, all of these operators combine, they do the mathematical operations that we're familiar with. So if we have numbers, then we can do something like this, complex minus number plus pi times 1, we will get a result. So those operators operate as we expect if we have numbers. Now, if you don't have numbers and the only type that doesn't have number is a string, not all of them apply. So for instance, you can't take string 1 and subtract string 2 from string 1. This is an unsupported operation. You cannot multiply two strings. You cannot divide two strings. The only operation you can do is to add two strings. And if you add two strings, this is what we call concatenation. Simply speaking, Python will just stick these two strings together. So you will get another string, which is the concatenation of the two strings, str1 and str2. The other operation that we can do with a string is to multiply it by an integer number. What? Multiply a string with an integer number? What does it do? Well, let's try. Let's take number, num, and multiply it by str1. What Python do will repeat the string as many times as the integer here specifies. It basically repeats the string as many times as the value of that integer. This is an interesting kind of feature in Python, and it also operates on any sequence, such as a list, as we will see. So those are the two operations that we can use with a string. We can add two strings, or we can multiply a string with an integer. Now it's asking us now to report the type of each one of these operations. So for instance, the type of this one is complex. I know that, right? It has plus 4j, so this is complex. But if I take complex out of the equation, if I have num plus pi times 1, I'm gonna get a float here. Similar speaking, type of this one will be a string, type of this one will be a string. So let's do type of this one. It's a string, and type of this one is a string. Now it's worth talk a bit about combining numbers from different types. When we combine numbers from different types, such as an integer and a float or complex, Python is going to promote all numbers to the more general data type. So if I have two integers, number plus number, I'm gonna get an integer as a result. If I have two floats, 1 plus 1, I'm gonna get a float. So that's not surprising. Now, if I have a number, an integer, and a float, Python is going to look here and promote number to be a float. So I will get 5.0 as a result. Similarly, if I have a float and a complex, it's going to promote the float to a complex before doing the operation. So that's always the rules with number. As long as the operands have the same type, you will get something that shares the same type, except for division. But if you're combining operands of different types, they will be promoted to the more general type. Finally, this question is asking us to report the numerator and denominator of number 3.5. So because n here is an object, we can use one of the functions, which is a function as integer ratio from the float type, and that will give us this number as an integer ratio. Again, don't forget that variables in Python are always objects, and each object have access to all of the functions and attribute of its data type. N is a float, you have access to all of the functions of the float data type, including the function as integer ratio, needed to answer this question.